let's do this again, guys. Get ready for benchmark number 1. This is review number 2. I've given you other ones, but let's do this real quick. See, once you see this stuff, guys, you want to think of list and spreadsheets. List and spreadsheets, menu 413. I'll show you the faster way, but you have to be ready to do it. It's pretty easy. Just got to trust yourself. But for sure, I want you to do this one, list and spreadsheets. And go to the document, list and spreadsheets. I believe it's 6, 1, -5, -6. Come down here. Let me just double check. Actually, it's 6, 1, and -6, -5. Okay, and we're going to come out here and go to menu 413. And then it's going to be here, and then control this left-hand side, enter, enter. And so the question was looking for your slope and your y-intercept. Actually, I didn't read it to you, but I just, man, automatically, that's what I'm always doing. Sorry about that. Let's go back and check it out. Again, 0.5 and so yeah, it's going to be looking for your slope and your y-intercept. So your slope, I'm actually going to type that in there. See, slope, you want to go ahead and be, I think it's a 0.5. And remember, this is a point, so it's asking for your coordinates. So this one you do 1, 0, and then, ooh, where's the negative? I'm going to say that's negative. And that's basically what you want for that one, okay? Let me see, make sure that slope is, go back to the calculator, 0.5 and -2. What did you tell you about this one? That's using the calculator, check, it works out. If you use your brain, you can use it and figure it out like this. So the y-intercept is where it's crossing. It's crossing right here at a -2, right? But if you look at that coordinate right there, that coordinate really is a 0, -2. So -2 works, but the way they want the answer as a coordinate, so you have to use 0, -2. Now this slope here, it's going to be, I'm going to pick that point, and I'll pick that point. Pointed where they cross, you know, where there's little black and the gray parts where they're crossing like that. And I do my rise of 1, and a run of 2. So it's going to be rise over your run, which is your slope. Load. We're going to rise 1 over 2, which is also equal to 0.5. So realistically, you can put a fraction there, or you can go ahead and put 0.5. And that's it. And the next one, let's see. This one here is going to be, okay, which two? So I'm not going to lie to you. Once you see the 2 lines, this is your answer. Without reading it, that is your answer. Okay, let me see. So, which ordered pair represents a solution to both equations? So, for it to be a solution, it has to be where they're crossing. Okay, what that means is if I only pick this point here, it's only on this one. It only solves this one. Basically, it only works with me because of those points. But those numbers to the x and y equals mx equals b. So it only works good for that one. But if you pick this one, it only works for this line right here. And it has the y equals mx equals b formula too. But in this situation, you click this one, it's on both lines simultaneously, and it's going to go ahead and be the solution to both equations. So let's do that. Next one. Okay, college has 2 classrooms of students, so we'll go with classroom A, and that's what they do. Okay, classroom A and classroom B. Classroom A has 70 students, so this one has 70. Classroom B has 30 students. Okay, that's a starting point. I can tell you that much. It's already going to be y equals mx plus b. But it's probably going to be y1 and then y2 equals mx plus b. Let's see what happens. Classroom A sent groups of 4 guys. That means 4x, okay? And since they sent it away, it's going to be a -4x. So for this one, have y equals a -4x plus 70, starting point, positive 70. This one's going to be sending them away, so it's minusing from them to classroom B, and to both have the same. So then this one, instead of this one, okay, well this one's leaving, so it's negative. And so in this one, they're going to be receiving them. So how do they receive them? They receive them in groups of 4. So they receive a positive 4x. So we're not going to put a positive 4x, which is put a 4x, which is positive. And then saying, where are they the same? So this situation, two different ways of doing this one. Okay, I already told y'all, once you see that there are two equations, I would love to use menu 3, 2. Come up to your calculator and go to calculator, two equations, so your menu 3, 2, two equations, enter. The first one I wrote y equals, and I know they're giving them away, negative 4x, and they start off at 70. The second one, they're going to have y equals, and they're receiving the groups of 4, I'm sorry, and they're starting off at 30. And it makes sense because they're going down from a higher number, and these guys are increasing, and they want to know where they'll be the same. That's where they're equal. Enter. So 5 and 50. They'll be equal at 5 movements, 5 groups, and they'll be equal at 52. So that's one way of doing it. Okay. So come back over here, and 5 is your answer. What's the translation rule? Okay, so this one, look, it's still the same, orientation, the way it's pointing. It's still the same orientation, so that's going to be a slide. You can just tell, it just slid the figure over. So let me see, I'm going to go, forgive me. That's a bad drawing, but it's all right. And I can translate it down to this one over here. And it stays the same without turning it. That's going to be a translation now. This one's the old one. We call it the pre-image. And this one's the image. So it went from here to here. And I'm just going to pick this point. It went to the right, 1. And since I'm going to the right, this is your x-axis, this is your y-axis. That's going to be x plus 1. And now it comes down, 1, 2, 3, 4, 5, 6, 7. And you just change that up. Different colors so you can see. So now I'm going to change it from the right or left. I'm going to go down. This is my y-axis. 1, 2, 3, 4, 5, 6, 7. So y minus 7. So that's basically the answer. X plus 1. I go to the right. And you know the one without any of these little, you see these little lines, they're like little apostrophe, but supposed to be a little line. So this is the first one, this is the second one, so it moved to the right, 1, and it came down. So this is the one without any little dot, apostrophes up here, is going to be the original one, and then it came to the right and down. This is the new one, old and new. We're going to x plus 1. Y minus 7. X plus 1, y minus 7. Plus 1, y minus 7. Alright. Okay, we're back. So this is going to say which one's showing a translation, SL for slide. I can see it already. And the slide, basically, it doesn't change the orientation. The orientation is the way it points. So I'm going to draw. And the orientation stays the same, and it keeps the same angle, everything. So I'm going to slide it here. You can see how it just slid it. So you can see the original one. So according to this whole thing, it's on the bottom corner. And it just slid it one to the right. So in the bottom corner here, and it just slid it to the right. Same thing. Okay, that's my answer. A. This one, you see how this line's vertical, and this line stays vertical? So no, that's way off, not even close. This one flipped it from this way to facing that way, but either way, that's my answer. Okay, translation means to slide. What translation or rule? So give me the rule again. So I'll give you a couple of seconds real quick. Which one is the original one? The green one, okay? Because it has no dash, like that one looks good. This one is the original one, and so first off, they're going to say go always right or left, so we're going to go to the right. So it can be in line. Y is moving to the right to be with Y prime. 1, 2, 3. So we're going to have 1, 2, 3, and that's off of the x-axis. You got that? The x-axis is going to the right. So it comes over here. It's very sneaky that they switch these things up. That's actually really good. Really sneaky one, but that's cool. Then y plus 3. So you have plus 3. Now, since I've moved this way, now I should got to move it all the way up to be in line with this one. So I go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would be plus 9 on the y-axis, y plus 9. So we're going to x plus 3, y plus 9. So we come out here, x plus 3, y plus 9. That's actually not that good. They shouldn't have the plus signs there. To make you actually think, right? Too easy of a question. Okay, this one's just doing some scientific notation. Match each number in scientific notation to its standard form. So this is not even standard scientific notation. So I don't know if we should match that one up. We'll figure it out though. So this one says move it 3 to the right. So 1, 2, and basically add a 0 there. All right, which would be that one. So that one should go here. And then this one says move it 3 to the right. 1, 2, 3. It's not in scientific notation, but you can still move it 3 times. 1, 2, 3. So that one would be this one. This one says move it to the left. 3 negative to the left. Ready? 1, 2. So it'd be a decimal here and a 0 here. So a 0 in front. It'd be that one right there. Yes, sir. ¿Cómo estás, Monsieur? Okay, so and then this last one, this one comes down. All right, so you're going to drag and drop, and that's where they would go. Just a few at a time. Okay, translated 5 units to the right. I mean, 5 units to the right. And then again, on the x-axis, if you go to the right, this is the x-axis, it's positive, negative to the left. Y-axis, positive going up, negative going down. So 5 to the right would be plus 5. Oh, that's the only possible answer. Okay, so let's check that out real quick. Plus 5, all right, good. And then 3 up. So plus 5, oops. Plus 5 means going to the right, plus 5. Up. Going up now, let's go to positive here, plus 3. And there she is. Okay, so on this one here, they want to go ahead and figure was transform. Transform means reflection. Come on. Okay, so again, the transform or transformations are all of them. Transformation would be the first one we covered was a translation, and then it'll be the reflection, and then it'll be the rotation. And all these are congruent. We have congruent transformations. So basically, the figure stays exactly the same size. The last one we have is a dilation. And the dilation is like when they dilate your eyes, it becomes, I'm going to say just the truth, not congruent. It gets bigger or smaller. And congruent means the same size. So this row here now says, well, look, from here, just like that. Oh, so you got to remember the rules. I'll tell you this, for it to be a rotation, you're going to have to come out here and see that y and the x switched already. So it's not a rotation. Okay, and then a rotation, it is a rotation. Let's just come back to sliding. The sliding part, you're going to see no. For the sliding part, you're going to look for x plus something, or an a and a y plus a b. That's not there, so let me translation that one. A reflection, for it to be a reflection across this, the rule would be, or x and y would be the first thing. And then for it to go over the x-axis means that x stays exactly the same. To go over the y stays exactly the same. So this is not that, so these are out. Okay, then, how do I say? I think y'all should know that one already. That's a 180. I'm trying to beat around the idea of just saying you should know that memorize, but that's just basically it. So go ahead and write the rules for the rotations. This would be x, y. x, x, y, y, x, x, y. We're going to go clockwise. So clockwise, then negative goes here first, and then to both, and then to 6. So right here you see 180. There it is. Okay, for this this is just easy. It says reflection, which is the reflected rule? Reflected means fixed life. And say which one's the one saying fixed? When it's fixed, well, it gives it to you right here, the y. So the original thing is x and y. When it says fixed, remember it doesn't move. So the y will stay exactly the same. And the x's are now opposites. So look for this rule here. For the y stays the same, fixed. And there she is. Okay, so polygon of the coordinate grid was this location of a certain point on the polygon. The polygon is transformed using this rule. Guys, when they're written next to each other like that, remember to do 3x means 3 times x. 3 times x. So when the word times, I told you to remember always the word dilation, and always remember the word scale factor. Okay, there was 2 rules. It would get bigger, enlargement, if that number, if it's greater than 1. There would be a reduction or get smaller. If it's less than 1. Okay? So here it says, if I had ax and ay, so it means the multiplication, your scale factor on this one is a. Now a is the number. A times x and a times y. So if it's going to be a big number, like 2, it gets bigger. If it's going to be smaller than 1, like a half, then it gets smaller. So if a is greater than 1, it's congruent. No. Then it would be greater. If it's between 0 and 1, which is like half, then it would be congruent. No, it would not be congruent. It would get smaller. Oh, okay. Okay, if a, again, a is the one that we're multiplying by here, and I'm saying like 3x and 3y. We're multiplying by the 3. And we're saying if a is equal to 3, just going like that. If it's greater than 1, the image of polygon would get smaller. No, it would get bigger. Okay, so that one's out. So if the last one, please be correct. If a is between 0 and 1, and I'm going to go for that one, say like a half. Half is between 0 and 1, so 1 half x and 1 half y. The polygon gets smaller. Yes. Finally, we got the right answer. See? Okay, so here, oh, 1/4. You can see already, guys. You can see this. This is already, now without even reading it, just opened up right in front of me. And the word dilation. Dilation means to be what? 2 times? I'm sorry, I always said to multiply, right? Multiply. And here it's multiplying by 1/4. So your scale factor on this one is 1/4. Okay, so your scale factor is 1/4. Means it gets smaller because it's less than 1. Okay, let's see what happens here. Oh, same idea. So the new one, these are the new ones, would be definitely not larger because remember the scale factor we said, the scale factor is 1/4, and scale factor 1/4 less than 1 would make it what? Not greater. Factor is less than 1. Okay, the pentagon, the new one, is smaller than the original one because the scale factor is less than 1. Perfect. The new one is smaller because the scale factor is greater than 1. And that's it. That's pretty easy. Not too bad. We gotta get ready for benchmark number 1, guys. These are our, I guess, reviews heading into Friday. Okay, so this one you're gonna go Friday, system up, finish it up, and then you get ready for the weekend. You're gonna be, these will be open on the YouTube, to watch over the weekend and get ready. All right. Well, that's it. Thank you all so much.